All right, I'm going to give you some help with homework number 1, part B. And hopefully that'll help you for some of the rest of the problems. So I need to draw all reasonable acyclic structures and a good 3D representation for the molecules listed. So I'm going to pull this down and then we'll work up here. So I needed to do that for C3H6. When we're drawing these organic molecules, we draw all the carbons in a row. We know that all carbons need a total of 4 bonds, but if I were to just fill in the remainder of the bonds that are not shown on this structure, you would see that there's too many lines and not enough hydrogens. So I have to represent only 6 hydrogens in this molecule. That means one of the carbons, either the first or the last, has to be double bonded with the central carbon. Now, when I do that, that means to fill in a total of 4 bonds to get a complete octet for every carbon, I now have 6 hydrogens. All right, so I need to represent this 3-dimensionally. All right, so there's more than really one central atom. This is a central atom because it's connected to 2 or more different atoms. Not necessarily different atoms, but 2 or more atoms. This carbon is a central atom because it's connected to 2 or more atoms, and this carbon is a central atom because it's connected to 4 atoms. So what I'm going to do is I'm going to write next to each carbon, which is considered a central atom, I'm going to write its basic geometry. I'll do it in blue. Okay, so this one has 3 regions, therefore it is trigonal planar. This carbon is also connected to 3, or has 3 electron regions, so it is trigonal planar. And then this carbon is connected to 4 regions, so it is tetrahedral. Okay, so how do we actually draw that? All right, the easiest thing to draw this 3-dimensionally is to start with the carbons. So I'm going to start with 1 carbon here. What's usually done is there's a line drawn down at an angle to connect to the next carbon. And then there's a line drawn up. So they're usually represented in like a zigzag orientation. The only time that changes is when you have a linear geometry and then everything's straight. So let's start with the carbon on the very left. So to represent that it has, I'm going to move this a little bit, to represent that it has a trigonal planar geometry, that means it's like a triangle coming off of it. And it's flat, it's in a plane. So one of its attachments is to a hydrogen and the other attachment is to a hydrogen. All right. Same thing with my next carbon. So it's connected to 2 carbons and then the last connection is to a hydrogen. And then the carbon on the very end is actually the most difficult one to draw. It's tetrahedral. You're going to have 2 lines, which means I have 2 bonds that are in the plane. And then I have one that's a wedge and one that's a dash. Everything else is a hydrogen. So this would be an acceptable 3-dimensional structure. If you want some more practice or you want some more help on this, please let me know. Hopefully this helps.